So number 11, Mrs. Falcon came up with the equation T equals -6a plus 85. So that's an example of a trend line or a linear regression model or line of best fit. They all mean the same thing. And anytime that you have a trend line, it's in y equals mx plus b form, isn't it? I mean, they're not using y's and x's, but it's in that same format. So this is relating the number of absences from class and the chapter test score, which graph shows the residuals for the data from the table. So what's the formula for residuals? Subtraction problem? Close. It's actual minus predicted. I always remember it as A minus P because A comes first in the alphabet. All right, actual minus predicted. Where do you get the actual numbers from? Do you get it from the trend line or from the survey or experiment?
Survey experiment.
From the survey/experiment. So it's actual. It's your actual data that you collected, the actual test scores that her students actually got. Those are my actuals. My predicted comes from what?
The trend line.
From the trend line. Because the trend line is used to predict stuff that maybe we didn't test for. So this data that we have here, the absences are my inputs. The test scores that are listed here, are those my actual or predicted? Actual is correct, because the predicted would all have the same value for a particular input. Like here we have 3 inputs with 0. The fact that they're all different, those are my actual. Plus these are what her students scored. So that's from the survey or experiment. We do need to come up with the predicted ourselves. How do we do that?
We take the middle of the median.
Well, here's a hint. The predicted comes from the trend line. So here's my trend line. If I plug in my inputs, that's how I get my predicted. So like here's an input of 0. So I plug that in for the A, because A is for absences, T is for test score. What's -6 times 0?
0.
And then 0 plus 85 is
85.
So my first predicted values for when the input is 0 is 85. And they should be the same for each input of 0, right? And I'm not going to find all the predicted. I don't think you need to. Just do it enough until you find the graph that matches. Like that, the other ones could not be it. And then do your residual, your actual minus predicted. What's 95 minus 85?
15. Or 15.
What's 80 minus 85?
5.
Oh, negative.
-5.
Oh.
What's 75 minus 85?
-7.
No, it's 2.
All right. Hold on, listen, children. You guys are talking too much. So for the residual plots, here's how they are formatted. So there are coordinates plotted, right? The X is for input. And the Y is for the residual. For the residual plots. So clearly, like I have 3 inputs that are 0. But I had 3 different residuals, didn't I? So that means on the 0, I should have 3 different dots, and they should be at these locations. So like for answer option A, are there 3 different dots on the 0?
Yeah, two, there's two.
There's
Oh,
3
there's
total,
three,
but
there's
2 of them
yeah.
are the same. Make sense?
Oh.
So it shouldn't be A, because they should all be different, right? Would it be B?
No,
Because are there 3 dots on the 0?
no,
So no. Could it be C?
no.
Again, same thing, only has 1 dot, there should be 3. Can it be D?
Yes.
Yes.
And if you look at the dots, do they match what we said they would be? Yes. So you don't necessarily need to find all of them, all the residuals, but find enough to where you can cancel out the other options. Whoever was after Baron, you go, back, and then you after her. All right, which other one do you need help on?
12.
Number 12. All right, so this one. Roger is measuring the length of a hanging spring as various weights are added to it. Using these measurements, he obtained the following regression equation. So I'm always going to highlight the equation because usually we have to use it. Notice it's also in y equals mx plus b form. And it says that y is the length of the spring and x is the mass in grams. So then it's asking what's the meaning of the coefficient 0.006 in this situation. So is that 0.006 my slope or my y-intercept? My slope, because it's in front of the x. What is slope also called?
Oh, wait,
Rate of change is what I was looking for. So that's how much something is changing by. So I guess you could say that's what's being multiplied by the mass. And then it's added to my y-intercept. I know it's not asking what the y-intercept means, but what does it usually mean? Like your starting amount. And in this case, it would be like starting length, I'm pretty sure, because it equals
yeah.
length, so that would make sense. There's already this length and then they're adding to it. So then read each of these options and just kind of sort them out. It says the stretch of the spring by a weight of 1 gram is 0.006 times of that caused by the weight 11.5 grams. Didn't we say the 11.5 is for length?
Yes.
So it can't be A. We have the length of the spring increases by 0.006 centimeters for every gram added to it. Does that sound like it would make sense?
Yes.
Yes. I think that's the answer, but let's cancel out the other ones. So the weight of 6 grams stretches the spring by 1 centimeter. Is that it? No, that's not even the same number. A weight of 11.5 grams stretches the spring by 0.006. Again, the 11.5 should be length, not weight. So the answer is B. So slope is always like rate of change. Make sure you can figure out what x and y represent, and you should get it on the test. All right, any others? Number 9. All right, so this one. Luckily, since the retake is not for your response, well, I mean, some of it is, but it's like the test you already took. This one's also multiple choice on your retake. So when it talks about line of best fit, where should your line of best fit be in relation to your data? Close to it, above it, below it, through it? Through the center of the data is the correct answer. So this graph is actually really strongly correlated. It looks like it's in a straight line already. So then if I'm envisioning a straight line going through it, through the center of it, it might look something like this. And hopefully I can get it to work. Now that it's the end of the day. Alright, so pretend it's a straight line, but that most of the data is in a straight line anyway. So then we should be able to cancel out some of these answer options based on like slope or y-intercept. Unfortunately, like this is a positive slope and these are all positive, so I can't really base it off negative slopes. So what answer option based on slope or y-intercept can we eliminate?
B.
Why B?
No, I said D.
Okay, why D?
Well, you said eliminate, right?
Yeah, which ones can we eliminate?
D because I selected that and it said I got counted wrong. But
Okay. Why do you think it cannot possibly be this?
Well, one, it doesn't start at 45.
It doesn't appear to start at 45. It looks like it starts between 25 and 30. So 45 is just too far off, isn't it?
Some people wrong.
So what else can I eliminate too?
B.
B for the same reason. 40 is way up here. It looks like my graph starts in between 25 and 30. So we're torn between A and C. I can't really throw one out because it looks like the graph could be 25 or 30 for the y-intercept. So then look at the slopes. A slope of 1 would look something like this, and I'll just start it at the origin just because. All right, a slope of 1 would look something like this, up 1 over 1, up 1 over 1. A slope of 4 would look something like this, up 4 to the right 1, up 4 to the right 1, and it's pretty steep. Do you think it looks more like the red or the blue?
Blue.
Probably the
So then A is the best option. The slope is pretty steep, and it looks like the y-intercept can be 25. Questions on this one? All right, so process of elimination is your best bet. Which other ones would you like to see? Number 7. All right, so a survey was conducted on whether a student had a curfew and if they had a cell phone. The results are shown below. What is the relative frequency? So that word right there tells you your answer should be a decimal or a percent. What's the relative frequency of students who have cell phones and a curfew to the total number of students surveyed? So how many students have a cell phone and a curfew? 12. 2 categories at once. Would that be my numerator or denominator? And what am I dividing it by?
52.
Because that's my total number of students surveyed. So all vocab aside, if you just read it carefully, you can figure it out. Of students who have cell phones and a curfew to the total number of students surveyed. So when you put that in your calculator, you get a long decimal. You get 0.2307669, but it says to round to the hundredths with a TH. So what number is in the hundredth spot right now? Wait, that's the 10th spot.
3 is in a
3 is in the 100th spot. Anytime that you're rounding, what number do you look at? The number to the right of it. If that number is 0 through 4, then that 3 will stay a 3. If it's 5 through 9, then we round up. So is my answer going to be 0.23 or 0.24? Good. So you should have put back. I had to go in and give you points if you put it without the 0, which is the same thing. I also gave you points if you put it as a percent. But if you put it as 24% or 0.231, I didn't give it to you because you rounded wrong. So now you know. Questions on this one? Questions on other ones?
3.
Number 3. All right, a teacher is comparing the means and variability as measured by standard deviations of male and female students' test scores based on the table below, which statement is correct? So, let's see. Here's the male test scores, here's the female test scores. It looks like the males scored between 80 and 90. And the females scored between 70 and 100. So we're talking about which one has more variability. What does variability mean? Good, exactly. So more space between the data points. So then which one has more variability, the males or the females? Good, they have more variabilities. So which answer option says that? Well, actually first there's multiple things in here. It talks about the means. What's the mean of 80, 80, 90, and 90?
Oh, we should find that, wait, no.
Okay, let's see. How do you find the mean of stuff?
Add them together and then.
And then divide them by however many you added. So what will I divide by in this problem? 4. So my mean for the males is, so 340 divided by 4 is 85, right? And then the mean for the females, so 70 plus 70 plus 100 plus 100 divided by 4. Is also 85. So the means are equal. So cross out anything that says the means are different because they're equal. And then it says, like we said, female scores have more variability. So is the correct answer A, someone?
Yeah.
Okay, great. Questions on this one? Any other one? Use your test score. So it looks just like this test. If you have a question, don't check. Twice. 14. All right, 14. Oops. All right, so 14. A music band has released 11 videos available for public viewing online. Thousands of people have commented on these videos and many more thousands have viewed them. The relationship between the number of thousands who have viewed a video X and the number of thousands who have commented on a video Y is modeled in the equation below. I always take notes so that I know which is which. It tells you views is what X is. It tells you that Y is comments. So just keep that clear so you know where to plug something in. So when it says on average, how many views are required in order for a video to gain 3 new comments? Where am I plugging in that 3? For the X or for the Y? Does it want to know when the video will get 3 new views? Or comments? So it has to go in for the Y.
Yeah.
All right, so that's what we show here. We plugged in the 3 for the Y because the 3 is for comments. And we're solving for the views, which is X. So get rid of what's farther from the X. Instead of adding this decimal, we subtract it on each side. Instead of multiplying this decimal, we divide it on each side. And this is what we get. Now, can I have 0.67 of a view?
No.
No.
No. So the minimum number of views I need is this, the 7,759. But look at our answer options. It's on an answer option. So can I have 100 views and get 3 comments?
No.
Can I have 1,000 views and get 3 comments?
No.
and I have 10,000 views
Yeah. You can also
to get
have
3
like
comments. Yes, but which one is like the minimum?
oh, like sometimes.
The 10,000. All right, so that's where you get that from. Questions? Any others from the test?
No.
So yes, did you go over? I don't think I did. Let's look at it. All right, a lot of people got this wrong. I think you guys are just being lazy, honestly. But here's how you solve it. I'm glad someone brought this up. So the following is an ordered list of monthly average gas prices in 2005. Are they in numerical order?
Yes.
Yes. So that step's already done for you. If they're not in numerical order, put them in numerical order. What are the 5 data points I need for box and whisker plots to end? What are those called?
The maximum.
Maximum, minimum. And the
Q3
median. And the Q1. Good. Yeah. So that is correct. Hold on. These are the 5 values that you need. Know that the median is also called Q2. And this is my lower quartile and my upper quartile. So if you can identify all of these, you should be able to pick the one that matches. So what's my minimum?
1.8.
What's my maximum?
90.
290. And what's my median? Well, there's 2 numbers in the middle. We need to take the average of them. What's 2.3 plus 2.48 divided by 2? 4.78 divided by 2 is 2.39. So that's my Q2. So that should be on my box and whisker plot. And then, so since it's between these numbers, when you do your crossing out for your upper and lower quartile, it should look like this. You never cross out your actual median, which is that. So I have to take another average of these. What's the average? That one I think I know. Without doing math. Is it 220?
Yeah.
I think so. Someone check. And then this one here, my Q3. I can find that average. And then I'll double check the first one. Okay, yep, I got the first one right. And then 2.63 plus 2.77 divided by 2 is 2.7. So all of these that I circled need to be on my box and whisker plot. Which one is the right answer?
The
So let's see if it has them all. So this one is the $0.190 right here. So this one's just before it, that matches. So 220, good, matches perfectly. The 239 for the median, again, right before the 240. The 270 matches perfectly. And the 292 looks like it's in the right spot. That one you kind of have to approximate more, but it looks good. Does that make sense? Yes, no, maybe. All right, I'm gonna start